before you get into that, give me just 1 minute. I always forget. Let me see if I can explain this. Here is the variance for the population, right? Right? Okay. There's one little tweak. If you're already looking at the formula, you can already see there's one little difference for a sample. Now, let me try to make sure and see if you can explain this. One level is, it's a formula, you plug shit in and you do it. Right? That's a horrible level to start with. Here's the reason why it kind of works this way. All right. There's currently an average age in this room. It's going to be a quick thing to be able to talk about. Cool. Right? And so there's a spread, there's a standard deviation of everybody away from that mu, that mean age. You guys are a population. If I took a sample like this row, is their average age likely going to be the same as the average age of everybody? What would you say? No. So let's pretend like I happen to pick a row of really young people. So their X bar, what's X bar? Sample mean. The sample mean of this row will be smaller than the actual mean. These people in this row, will their ages be closer to their mean than it will be to the mean of everybody? Yes. Totally, because their mean came from them. Their data points, their ages will be closer to it. I really want to make so when I have a sample then, if I use the same formula, it's always, what's it going to come out to be? If they're closer to their mean, that means the spread is going to look like it is smaller than it really should be. So how do I correct for that? So this is just a correction because it's only a sample. It's the fact I only know X bar, I don't know mu. So to cover my ass, I do this little correction here. So here's all my sample stuff. I don't divide by n because that's going to come out too small. If I want the number to be bigger, I have to divide by less. And what ends up working perfectly is that. So this division by n minus 1 instead of n, right, the division by n minus 1 makes the answer a little bigger. It actually makes it more honest. It makes it more true. So again, is everybody cool with the fact that they're going to be closer? Their ages will be closer to their average age than it would be for the whole, than it would be to the whole, the average of everybody.
But why minus 1?
Oh, I got you. So one reason is, again.
1 would not make.
Say again?
1 would not make.
Yes, it would. If I divided here, instead of dividing by 5, I divide by 4. Don't I get 4 here? And then this would be 2. That doesn't sound like a big difference, but relative to the size of the data, yeah, that's a big difference. So yes, it does change things. And really, let me see. 3. So far, semi-cool. Standard deviation formula has a slight difference. Why? Because it's only a sample. That's a correction for it only being a sample. If I took every sample I could in this classroom, calculated all those standard deviations using this formula, and then averaged them, I get the same thing I would here. If I don't do this, it's wrong. So what we say is this targets the real standard deviation better. In fact, it targets it perfectly. Now, one last thing about n minus 1. We're going to see this n minus 1 later this semester, so let me just say this. So again, n minus 1 is there as a tweak to the formula when I only have a sample. When I only have a sample, do I know everything? No. So then I should expect there to be some kind of tweak for that reason. We're going to see that the whole semester we're going to see something. If I don't know everything, I got to somehow cover my ass somehow. Okay. Now, look at n minus 1 a little bit closer. If I have 4 data points, and I want the average to be, 10, with the mean to be 10. Do you know anything about the data points themselves? I don't know what each data point is, but I do want to know what they add up to be. What's the only way to get an average of 10 from 4 data points? What do you divide by 4 to get 10? 40. Really think about this. The sum of the data points divided by n equals 10 in this case, right?
Yeah.
So there's 4 data points. What must they all add to be then? They gotta frickin' add up to be 40, or else their average is gonna be something else. So we do know one thing, they have to add up to be 40. So how many of these data points can I just make up until I gotta be careful to make the sum come out right? So the first data point, let me say it's 7. And then let me make the next data point 13. And let me make the next data point 20. What does the last data point have to be?
0.
See, I can't just make up the last data point, can I? There's a specific thing it must be. So how much freedom do I have when I have 4 data points? How much freedom do I have? 3. I can make 3 of them up. And then the last dude's got to make everything work. So this is called degrees of freedom. It's always 1 less than how many you've got. So we're going to see this later this semester again. This n minus 1 by itself is actually a huge idea. I can't show you all the math behind this, but if I take a bunch of samples using this formula and average those standard deviations, it's the same as the standard deviation of everybody. If I don't use this formula, it's not correct. So this is just a tweak, just a, what was I using earlier? Since it's a sample, I have to adjust the standard deviation formula to be this. All right, now I'll try that. So it's the same stuff. You're just using this formula because you have a sample.
Nah, I don't think
What's up?
so. The bottom formula replaces the